the recording. It'll start here in a second, and then Shridi, I guess we're ready to rock and roll.
Great. Let's wait for a minute more until a few other people join us. Hey Ruth, that's completely fine. We're happy to have you in almost all the meetings. And yes, that is a nice mic. I agree there. You're not audible.
Lee, I think you're on mute.
Yeah, I think his mic's a little off today.
Like he's on mute, like on mute.
I'm not that good at reading lips. Nope. Still can't hear you. Alright, until Lee fixes mic, let's go ahead and start with the meeting. Michael, we have you up first. Is that okay?
Yes, now unmuted. Can you hear me?
Yep.
Okay, thank you. So my PC was behaving strangely all day. So if I suddenly vanished, then something happened, maybe. Yes, I thought about talking a little bit about the work I've been doing. I joined Layer 5 Meshery not so long ago. And when I was looking around for some issues I could work with, I saw the Meshery Consul adapter. And as I'm working with Consul Connect right now in my day job, I thought that would be a good way to exploit some synergies between this work here and my day job. And also I saw that the Consul version that was included or installed using the Consul adapter was almost 1 year old. And so I thought that would be a good way to start. I think if it's okay if I present and take the screen.
Yeah, sure. I'll just...
Yes.
Go ahead.
Okay, let me check. Entire screen. Yes, I think I trust you, so that's great. Only share, yes. So do you see my screen?
Not yet. Yep, now
Yes.
we
You see my screen now?
Yep.
Almost.
Yeah, okay.
Is it black for everyone else? I do see that you're sharing, but
No, right now it's not supposed to be black. I should be sharing the issues page.
It's black at the moment.
I'm still presenting.
Yep, I can see your cursor move. That is impressive.
Actually, let me switch off the camera. I don't know. You just have to tell me when you see my screen.
Sure.
Yeah, it's interesting. Michael, just like Trudy was saying, it is, or something is being shared, but what's showing up is just a blank black screen. Your mouse is visible when you move it.
Weird. Something's weird today. Let me check that. Just stop presenting. Okay, I try again. Actually, I wonder whether this is... How does it look now?
There it is. It's coming up.
Yep. Good enough.
So now you're seeing the issues page. Is that correct?
Yep.
Yeah, okay. So, as I said, first I thought I'd be starting with issue number 2 and also 1 to update Consul to the latest version. Then I saw the other issues about Helm and thought maybe that would be the best place to start. But then I went back to working on number 2, update Consul adapter. Use the latest version of Consul just to get familiar with the Consul, Meshery Consul adapter, and to have something which probably is a bit quicker to be able to finish than starting refactoring and including Helm. But of course, that's still an open issue and something we should be working with. We can talk a little bit about that if we have time. So I was digging into this number 2 and also number 1 because I was trying to deploy the Consul service mesh onto my local PC, and this is just one node, and then you have to adapt the Consul configuration to run just one server so that it goes on one node. And we talked about this a couple of weeks ago, that we think it's a good idea to just combine those two. What I then did, oh, this is not going to work. I guess, what are you seeing now?
Still on the issues page.
Still the issues page. Okay, but yeah, I can look at the code, I guess. Let me check. Where's the code? Here. So what I was looking at, I was trying to figure out how the original file was generated. VO branches. No, this is not correct. I'm sorry. I had completely different plans with sharing the screen, but you never know on a Linux machine with 2 screens. I think this one. Okay, we're getting there, I think. Yes. So I wondered how the original file was generated, and it looked like it was generated using Helm templating directly. And so I thought about trying to figure out the parameterization, but then in the end it was just as well to take the values file which defines the parameters for the Helm chart when it is installed or merged to give the template from the HashiCorp distribution from the latest Helm chart, which is probably still 24.1, and then adjusting these values slightly, creating manually from this Consul values file, the Consul YAML file. Something interesting that I discovered was that when you just use Helm to create the Consul YAML file, then you get a namespace called Consul. You still hear me?
Yep.
Yeah, okay, because suddenly it was really quiet.
No more traffic.
Yes. Anyway, so the default namespace, if you don't specify a namespace with Helm, is Consul in this chart. And this means when in the Meshery adapter you define another namespace, you could actually deploy Consul into the namespace that was defined in the Meshery adapter. But then stuff didn't really work. So I didn't really understand A, how this was possible, and B, why it's worked sort of halfway. So that's why I was then using set to just replace the namespace in the generated file with a namespace variable. And the namespace variable is the only namespace that is merged into the template in the Meshery Consul adapter. So that worked in the end.
Okay.
So, sorry?
Just a quick clarification or question on that. By the way, I have to admit, of the couple of PRs that you've had open, for my part, I haven't been through them much. So this might be covered already, but of the namespace of this variable here is, as a user navigates through the Meshery user interface, and they go to provision, they go to the console adapter page, and they go to, this is one of those things where you'll end up having to load up your cube config, maybe.
Why does it not work?
Yeah, I think it's because either it's that your cube config isn't currently loaded, or because the connection to the locally running console adapter isn't configured. Yeah, this is.
It was because I had to restart the browser because the mic wasn't working. So we're back on track, I think. So here.
Nice.
So this is my adjusted. Yes. So if you go to the console and you say, and you use the namespace here, right? And then you say test1, right? And then you deploy either the service mesh or the sample application. Then this is going to be deployed in this namespace, right?
Nice. Okay.
So I could write test1, and then it looked like Consul actually was deployed into the test1 namespace, but but it wouldn't work. So Consul wouldn't work because the namespace in the manifest was still Consul. That was really weird. But anyway, by then replacing, as I've shown here, the generated namespace Consul in this new file, and replacing this merge variable, and then it worked. Then everything, worked actually. Now, well, at least the first part. There was a lot of familiarizing and finding out and debugging, trying to understand what happened. Okay, so successfully I can show you that this works, but I don't dare to do it now. I did it before the meeting. You never know what can go wrong. And I can now show you the Consul user face, hopefully, which is running on my PC right now. And you see down here, if you can see it, that the version of Consul running here now, as deployed by Meshery, is 1.8.2, which is the latest, like a couple of days ago. You also see here at the top, Consul Connect or Consul has the concept of data centers. So you can have several data centers that you can see in the same user interface. If they're connected by federation, you get a list of services. You have nodes that are part of the Consul data center. Right now, we just have one node here on my PC. Then you also, in Consul, you have key value store. You have access control lists, and you have intentions. I can show them later in a couple of minutes. What I have done here, I have been using a application, an image which is developed and maintained by Nick Jackson. It's called Fake Service, and it's really great to sort of create service topologies and cold chain topologies. So these fake services just call upstream services. You can also return errors and a whole lot of sort of configuration options to test service meshes, for instance. So here.
Miku, did you deploy fake service using the console adapter?
No, but I could.
Okay.
I did it once using, no, I did it manually. I did also using, the custom YAML functionality to do that. But
did you?
Today I just did it manually using kubectl from the command line.
Because I think I'm losing track now because I think there's a few firsts that have just happened. I think that's the first time I've heard a user say, no, that wasn't supported, but I just went ahead and used the custom YAML option anyway. It's like, that's fantastic. That feature has been there for like a year, and I haven't heard that much feature. So that's great. Also, I'll say, well, one. You mentioned Nick Jackson, and there are some of us in the community that are on the call now that know Nick, and some that don't. But so Nick, for those that don't know him, he's in the Slack. He works at HashiCorp, which is the company behind Consul, the Consul service mesh, the pink one that the pink one that
this one.
Yeah, that Miku is showing. So Nick's very much so a friend of the community, and as a matter of fact, I'll tell you more about some of the things that he does with us. But one thing we're looking to do with him is exactly what Miku is showing, which is the fake service that's there in the Learn Layer 5 sample app that we use for SMI conformance testing. There's a different small sample app that was developed here. That one probably needs to go away and be displaced by fake service. Like this is a better sample app for us to lean into. And so I'm just excited to see that you're touching on. This. In part, Miku, because this fake service allows you to control the behavior of the microservices that are run. Maybe you don't want them to respond well. You want them to respond slowly, or so.
Yes. So you can, for instance, say that in 50% of your requests that the fake service should return a specific error code. And then you can see how this propagates, how this is handled by the mesh. I think the advantage of using fake services is that you don't have to think about what kind of application you have and how this is supposed to behave. And the UI, which is sort of included in fake service, also shows very nicely how they are connected. You see here that I have the API AAA service is actually used by 2 other services. Now, just quickly maybe go back to the management console. Then you see here that you have all the services on the node. You see the proxies that are deployed next to each fake service on each pod. And this is how most of these service meshes work, or all of them, that you have a proxy as a sidecar in a Kubernetes cluster. So this is in a Kubernetes cluster. Consul and many of the other service meshes also support other nodes than Kubernetes clusters. More recently, because this many have seen that the service meshes can help in modernization, and something you have in the legacy world is application on virtual machines. So that's very attractive to be able to include them in service meshes. Now, one thing I can show is intentions, because they were also mentioned in one of the issues. So you can, intentions allow you to disallow or allow traffic between specific services. Now, if you set up a service mesh for production use, then of course you would have security in place with deny all rules everywhere and access control lists. The deployment here is for exploration and with no security enabled. Now, if I create an intention, which denies all traffic from all services to all services, then I expect this service here, that was the wrong button, not to function anymore. And you see that this really doesn't work anymore. Now I can start, and in practice you have to do that. You have to start adding, allowing, say, from the web, which is the front end, to the next one, which is this one, and say this is an allow. I haven't practiced, so this is going to be interesting to see what happens. And you see it's calling on, but because the error returns an error, then everything is red, is still red. So you can just continue doing that. Service A is calling service AA, and service AA is calling service AAA. And I'll see what happens here. Now you see the A chain, if you like, is going fine, but the call to B, if you remember from before, is not going fine. So using a setup like this, you can sort of like play and start understanding how your service mesh works, and have both the visual feedback, but you also get JSON response, which you can then use in automated tests, for instance. So this is what I've been doing a bit so far. Let me go back to the issues if we have time, if that's okay.
Yeah, question actually on the. It's been a long time since I looked at intentions. Is it still the case that they're really only about access control currently? Like, is it just about allowing and denying traffic?
Yes. What are you thinking about?
Or other things that I could see that you would describe as an intention could be the fact that you want to rate limit the amount of traffic going into that service, for example.
No, it's just disallow the connectivity between services.
Okay. So newfangled firewall rules. Okay.
Yeah.
Cool.
I don't know how it's implemented. Yeah, probably. I don't know how they implement it. Of course. So going back to the issues. So I have been working with just fixing the two sample apps that are included, the HTTP bin and the book info. They have using old versions of the deployment manifests. So I'm ready and just waiting for these pull requests to be approved so that I can test them as well. And from then on, there are lots of interesting issues like Helm support, automated testing, stuff like this, and refactoring as described in, oh, this was the wrong one, here, in the Meshery adapter doc. I have also started a section here. When everyone starts with exploring something new, there are lots of questions that later become completely obvious, and where the answer is completely obvious after a couple of weeks working with it. Yeah, it's I've experienced this many times. So So I've tried to sort of like the beginner questions that I had, document it, and something is really slow here. I don't know what. In this document here.
Michael, this is a heck of a first demo. This is, I'm tickled at the stuff you're showing. I haven't, I think last time I saw, last time that I've seen Meshery deploying Consul, it was 1.5, right? Like you just leapfrogged us, I don't know, like a year and a half worth of releases. So, yeah, the fake, not to pile it onto you, but just the fake service that you were demonstrating, that's very much so a desired supported sample application for Consul and for the other adapters for that. Maybe one last, actually, you know what? I have got a bunch of questions for you. I should, I know we had a couple of other demos.
Yep, we do.
Okay, maybe I should, I'll hold off. Did anyone else have feedback for Michael or just questions about Consul, the adapter that he's significantly uplifted?
I think Abhishek would, but he's not with us on call today.
Sure.
So that's a bummer. Alright, thank you so much. Is it Michael or Mikkel? I'm not sure if I'm pronouncing that right.
It's Michael or Michu.
Alright, I'll go with Michael.
Lee is perfect, the pronunciation.
Michael
is. Yeah, it's perfect. I'm really touched, Lee.
No, hey, like, wait. Okay, hold on. Thank you. I'm very pleased I'm glad that you are. That makes me happy that you are. So I have to take a moment because for those that have been on these calls before, or if you go back and watch the embarrassing moments from many other recorded calls, you'll know that my American tongue is, only has so much dexterity when it comes to pronunciation, apparently. And but now that Shriti is hosting these calls, the tables have turned. Like Shriti, it's time. Go ahead and.
I'm happy, Sudhi. Definitely.
But Michael is really fine. So that's.
I'm going to go with Michael at the moment, and I'll definitely try and learn the correct pronunciation from Lee later on.
Very nice.
All right, thank you so much. Let's move on now.
Yep.
Right. Before we jump on to Anirudh, let's go with an introduction and an old embarrassing tradition. All of you who are new on the call, we have this old embarrassing tradition of having you introduce yourselves and say a couple of lines, and if you want to, you can turn on your webcam. If not, that's completely fine. So let's start off with Nikita.
Yeah. Hi Lee. Hi Shriti. Today is my first call, and I'm new to Service Mesh, and I'm Nikita. I think you would have known already. So so I am in the phase of learning of Service Mesh, and I am very much interested in getting in depth of this particular project because it looks suitable for many new cases. Like performance was one of the good use case of Meshery, which I couldn't get in any other project. So this is something new and interesting. So looking forward, and I will spend some more time in knowing more about this project and try to contribute as well for this project. Thanks, Lee, for giving the opportunity.
That's great. Welcome to the community. We're really actually happy to have you.
Awesome.
All right, moving on. I'm gonna pick on Shreyas now. Shreyas, are you there?
He left, I think. He's not there.
My bad. All right. Sahil, have you ever been on call before with us?
Hello, hi to everyone. This is first time I have come here, and recently I have certified in Kubernetes, but I am trying to contribute here, but I am new to open source. So now I am learning and learning, but from where to start, where to begin, I don't have a getting idea. I am in third year now, so I ended my sixth semester. I am trying to contribute here. Sir, please give me any measurement, so I will find out how to begin. At least I will find out.
Awesome. Totally. You're in the right place. Sahil, we'll get you introduced to some other folks in the Slack and a couple that are here who are more than happy to give you a tour, kind of get you integrated.
Yes, sir. Sir, I am interested in Kubernetes.
You're definitely in the right place then.
Great. I'll actually pass on some resources to you on Stack.
Yes,
After
sir.
the
Sure,
meeting.
sir. Sure. Thank
Great.
you.
Moving on, I think we have Joan. Are you? I'm sorry if I'm pronouncing that wrong, by the way. Are you joining us for the first time?
Sorry.
I think he left the call. All right, I think we're good to go. Anirudh, do you want to start on your demo of the APIs structure?
Demo on, like, I was not briefed or anything. Demo on.
It's not a demo. Let's just discuss the API structure. I think you
Okay,
wanted to talk about the Meshery
yeah.
mesh command response. Yeah.
So regarding the Meshery commands, mesh commands. Okay.
Yep.
I'll quickly bring up a doc.
Sure. Dave, are you ready for the discussion on your topic?
Yep, I am.
I guess Dave can start first. Like, for me, I'll have to open a couple of docs. So I guess Dave can continue. I'll get next turn.
Yeah,
Sure,
fine.
let's circle back to you. Go ahead, Dave.
Yeah. First of all, I'm audible, right? Because the last
Yeah.
time when I was on this laptop, the mic was not working.
Yep, you are audible.
Just a second, I will just share my screen.
Sure. Go ahead.
It's visible, right?
It's in the process of. Yep, it is.
Yeah, cool. Every time, I don't know why I'm every time on this slides thing and I press F5 instead of Control plus F5 and it just won't work. Yeah, so it should be visible now, the presentation, right?
Yep, it is.
Yeah, so in this basically demo or presentation, we are basically taking a look about this new tool that is Buff, which provides us a better way to work with protobufs. Okay, the protobuf, protocol buffers, whatever you say. So it's basically a new way of working with protocol buffers. And the goal of Buff is to basically make it a lot easier to use protocol buffers so that whenever someone will be comparing that what to use, JSON or protocol buffer or whatever, then the you can say the best choice or a very good choice will be the protocol buffer. Yeah. So before that, so why is this tool here? So let's talk about some problems that is with protobuf. So first of all, protobuf is not as widely adopted as JSON. Okay. It is actually not a problem. It is just it will take some time to get adopted. And another some things is the API structure. So actually right now, as it is not as much adopted, there are no standards that an organization can enforce on APIs, like API structure or something like that. So what can happen is there can be inconsistencies between the APIs, like API names, API structure or something like that. It's basically based on the design decision that someone will take some design decisions like, yeah, API should be all in camel case or something like that. Other than that, there is this backward compatibility. So there are times when you have to change your protofile, and what can happen is basically it can break your API. So why it can break your API? Because after basically changing your protofiles, you have to basically deliver the stubs that is used to generate the client for the for gRPCs or another software that are there. And another one is tooling. So tooling is basically the buff that will be a tool to basically use this protobuf wisely in a good way. Okay, so right now buff is there is no stable release for buff. It is right now in beta, and right now what it has is basically it provides us with some CLI tools and some Protoc plugins. So in that CLI tool, what we have is we have a linter that will basically enforce API design choices and API structure, and a breaking change detector. Some functionalities that it provides us, like if someone has used the protobuf compiler, so what it does is you have to specify every single file. Yeah, this file is there, this file is there, and all those things. But in this, you don't have to specify anything. It will just search. You have to just specify the root directory, and it will recursively search for protofiles in that. So there are a lot of linters and breaking checkers, because the thing is, some linters and some breaking checkers will work for some organization and some will work for some another organization. So organization can choose among these linters and breaking checkers that, yeah, we want to go with these linters and these breaking checkers. And that is another feature that I found like interesting is, so basically what buff does is it has its own internal compiler, and it's like 4 times faster than the Protoc, the standard de facto compiler for protobufs. It's like 4 times faster, and it's really interesting. Another thing, so in what we have now, I discussed that we have the buff CLI client, and another thing is buff plugins. So we can just use those plugins with the protobuf compiler, and instead of using buff as a standalone tool, we can just use plugins with the product to basically lint and check if there is some breaking change or something. And in phase 1, so this is about the roadmap that what they're building and where they are now. So in phase 1, they are trying to solve this API structure and backward compatibility issue. And yeah, as I have mentioned before, they are trying to solve this API structure enforcement by using linters and some plugins related to the breaking change. So they are trying, and by that they are trying to do this backward compatibility thing. Okay, in phase 2, this is really interesting about this tool. So I think some of you may have worked with Docker. So what it does is you specify a Docker file, you can build a Docker image, and you can push that Docker image to a Docker registry, maybe Docker Hub registry or some private registries, right? So now other can pull those Docker images from those registries, and they don't need access to the particular user, right, that who pushed those things. So this is really interesting. So what it's trying to do is, it will do in the future. Right now it's in the beta version, and it's just trying to provide us with the API structure and backward compatibility thing. In future, they're planning to provide us with this buff schema registry. So what problem will this solve is, there was this problem with stub distribution. So okay, we generated a protofile. Now we have to share it with our clients. We implement the server for the APIs, right? But we have to share it with our clients too. So that was the issue. Like, if you update something, then how are you going to like distribute it to your clients who are already using these protofiles? It can break things, right? So that's why they are trying to build this buff schema registry. So what we will do is, we will just use this buff tool. We can create images out of the protofiles, and we can push those images to the schema registry. And someone who is using these APIs, these protobufs, and then just can pull these images from the buff schema registry itself. Okay. Yeah, so I have prepared a little demo for this thing. So let's go to Visual Studio Code. It should be visible. Should I increase the size of this thing, like zoom in?
No, it seems pretty good.
No, it's pretty good.
Yeah. Quick question, if I may. I'm scratching my head slightly at the registry containing images. The images are what? The
Yeah.
sub.
Okay. Yeah. Okay. So the images are what, right? Yeah. Okay. So images is basically what product does is it basically creates file descriptor sets, right? The proto compiler basically generates file descriptor sets from the proto files. These file descriptor sets is nothing but it will just contain the information about the proto files like messages, services, and all those things. And using this file descriptor thing, the Go plugins, sorry, not the Go plugins, the plugins like Protocgen Go will generate code based on this file descriptor thing. So what Buff has done is it basically extends this file descriptor set. They have added some their fields like some metadata so that they can work on that thing. Now the interesting thing about that is uh, basically the image is file descriptor set and file descriptor set is image. So if we want to use the buff image with the proto, that is the proto compiler, the standard proto compiler, we can use that. What proto will do, it will just ignore these extra fields. And if we want to use file descriptor sets with this buff compiler, the buff internal compiler, we can use that too. It basically it will just not use those fields that was there. The concept on which this thing is based on is that the grp, sorry, not the grpc, yeah, the protobuf, it's basically provides us with this thing that is forward and backward compatibility. It's not related to the issue that I was talking about. It's something related to like if you add some fields, then it is not going to break your api. I will just show them in the demo too, so you can grasp it a little better. And file descriptor set and images are basically the same thing, but images are file descriptor set with some extra metadata. That's it. So did that answer your question, Lee?
Yeah, it did. Yeah, thanks.
Yeah. Okay. So yeah. So let's go to the demo. So okay. So let's just take a look at this proto file. Okay. So this is nothing, just a simple proto file in which I have defined a service. Let us say hello, name, and a welcome message will be returned. Right. Okay. So this is a simple proto file. So okay. How buff works is basically we have to define a buff.yaml file in the root of the directory. This buff.yaml file, and it will just look for configuration in those YAML files. I will just go over this file that what things are there and what it is doing and all that. So buff will look for configuration in this file, like what linter to use, what breaking checkers to use, and which directory. So this root here, this roots is basically telling us buff, okay, you have to check all those proto files in this directory. That is the current directory basically. And these are the linters. So basic is like a group of linters, and in this linter there are other linters, and we are just removing these linters from that basic group, and we are using another linter that is a file over snake case thing. Okay. And this is basically telling us that, okay, check for this type of wire JSON type of breaking change. So I have just changed some commands so that it will see over time. So this is the proto compiler, that how we use this. We have to tell it that this is the directory in which you have to look for the file, and we have to specify the file greater.proto or some, and then this go.out that you have to generate the code for Golang, and the directory in which you have to basically generate that code. So I think it should be generated in proto. Yeah, here greater.pb.go. So it is generated here, this code. So this was just a proto command. I just wanted to go over this, and based on this we can let's go to the buff compiler now. So the buff, what it provides us is, as I talk about, the buff provides us with automatic file discovery. So we can just do this ls files. Yeah, only greater.proto is present now, but if I just create a new folder, say something, and yeah, if I move this greater.proto in that thing, that will work too. So after this, so let's talk about the lint checking thing. So what it will do is buff check lint. If we just do this thing, it will check the lint. If it will check this proto file that is there in this directory, and all the proto files that are there in the subdirectories, it will check all of them recursively. So let's just run this command. These are the error that is showing. That is, we use the link, this lower snake case lint. Let me show you this. Yeah, here. So we use this lower snake case lint, and if you see the messages here, that is name, welcome message, are not in a lower snake case. That is why it is showing us the error about those lints, and it would basically we can check lint and enforce that yeah, right, there is some issue here, and we can change that. So this was about the length. After this, let's see about the breaking change. So for breaking change, if we want to see that yeah, something is breaking after this change, we have to compare it with something else, right? And for compare it to something else, we will compare it with the image. I just talk about what an image is. So let's just create an image by using this buff image where output is the file image.bin. It will just create a file, and yeah, here is this file image.bin. Yep. Okay, so now what we can do is we can do some change in this greater.proto file. Say I change this to int32. Now this will essentially break the APIs. Like initially the APIs was getting a string input. Now they're getting this int32. So this will break the code. So let's just check if yeah. There is this error message, and what is it saying is hello request, change type from string to int32, field 1 on message. So why is this here field 1? So basically how protobuf works is on the wire level, it basically do not use this name, it don't use these names, name or something, welcome message, it uses this number 1 2 3 or something that is mentioned here on the wire level. So that is why it basically is, I think it's showing the one thing here, because the name is changed from string to int32. That's why I just change it back, and let's see if there is a breaking change now. No, there is no breaking change now. So that is how this breaking change thing works. I want to also mention this one thing. So how buff is checking is, it is basically collecting all these proto files. It is compiling them like dynamically, not basically compiling and storing somewhere. And then based on that compiled thing, it is checking, yeah, there is some breaking change or something. Okay. Yeah, so the thing that I talked about, file descriptor is image is file descriptor, but with some extra metadata files, right? So what buff offers us is we can use protoc file descriptors with buff, as we just use image here, like in this command, buff check breaking minus against input image.bin. So let's just create the file descriptor for using the proto compiler, and we can create that with this. Yeah, here, it should be better.
Just to clarify, the way in which buff helps guarantee backwards and forwards compatibility with a given proto is that's primarily through linting. It's not a or yeah, I should stop my question there. It's through linting, right?
Yeah, actually about the breaking thing, I am not exactly sure about that. I will get back to you. But another thing, it is just using linter. And about the breaking thing, I have to check that what is this thing doing exactly. Okay. I will take a note about that, and we'll see that how this thing is working. So let's just create a file descriptor for this thing using the proto, that is the standard compiler, right? So there is this file descriptor.bin file that is just created, that we have just created. Now we can just pass it to the buff instead of passing the image.bin. So the command initially was this image.bin. Now instead of using image.bin, we will just use this. So let's see. Yeah, now there is no error, and let's see if we changes it to int32. Yeah, so there is this error. Let me just do this one thing. Yeah, so there is this error that is hello request change this to this. So right now we are basically comparing the file descriptor that is generated by the standard compiler, the proto compiler, with the by using the file descriptor that was generated by the proto compiler in the buff compiler itself. And so right now that is what I was trying to say, that buff uses this proto buff feature that is forward and backward compatible. Yeah. And the last thing that is that you can, instead of using buff, if you had already set up some plugins, tools, some thing in your repo, then you can just use this lint check. These are the plugins that Buff had built. You can just use this lint with the Proto standard compiler, and it will work. And yeah, one other thing I was curious, like, okay, so I know how to build images out of this thing, but at the end, I am not going to work with images, right? I am going to work with some kind of code. So it provides us with this internal compiler that is Proto, and we can just use this Proto same as we are using this Proto standard compiler. Instead of just using Proto, we will just use buff space Proto, and it will work similarly. So let's just do this thing.
This looks great, Dev. Just one pointer. We're kind of running high on time.
Yeah, no, it's just over. Like, this was the last thing that I wanted to talk about, and yeah, so that is it. So if you have some question, you can ask now. Or, we can just discuss about this thing on Slack or something. If you want to ask anything.
I totally do. I'm going to hit you on Slack for my part anyway. Publicly,
Yes.
others can jump in too. Yeah, Shriti, take it away.
Definitely. Looks good.
Okay,
We still have about 5 minutes to go. Nikita, do you want to elaborate on the issue that you brought up?
I was just asking, will Buff help people to adopt it over the REST way of calling?
Dave, I'll let you take that now.
Sorry, can you repeat that?
Yeah, so usually people are little means people are usually not very easy to adopt this protobuf kind of protocol. So they are very well adapted with REST endpoints. So how will it help people to adopt this over REST? This is definitely fast, but people have some constraint, like they do not want to adopt.
Yeah, actually, I talked about, right? So there was some issues like stub distribution and all this. It is trying to solve those issues, but other than that, what I think is, until and unless the browsers start to support this gRPC, people will most probably be using REST for a long time. The reason is gRPC only work with HTTP2, and so it might not work with every browser. And that is, I think, one of the reasons that people are not shifting to using protobuf. And it is solving a lot of issues, and people are slowly, but yeah, a lot of them are starting to adopt this thing, this gRPC's protobuf thing, and Buff is trying to help them adopting it by making it easier to solve some issues like say distributing the proto files, distributing these images, and enforcing some standards about the API structures and all that. That was the main issue that it is trying to solve.
Okay. Yeah, but the protocol remains same. That is HTTP2 only. That's why they get good amount of speed.
Okay, sorry. So that was a mistake on my part. So HTTP2 is only for gRPC. I was kind of mixing things, and it is not about protocol. Protocol is just like a protocol in which it basically tells us how we are going to serialize things and send it from one place to another. That's it. That is what essentially protocol is.
Okay. I think, yeah. Thanks.
Great. Nikita, did you want to elaborate on this issue that you created? Is my screen visible?
Yeah. So by default, when I open the UI, so this problem was by default I am getting sorry, this is related to CLI. So by default I am getting list of all meshes which Meshery is supporting, but there should be an option to a user wherein user can provide, like, I only want to get info about Consul and let's say Kuma. I don't want other meshes. So that was my point. Like user should be given option to provide the mesh name, list of mesh names.
Yep, it's a great. So, Shruti. Oh,
Yep.
no, very good. There was a short echo. Nikita, that's a great ask. As a matter of fact, it's been asked about in the past because, yeah, once, Meshery is great to help you figure out which service mesh to adopt. And then after you've chosen one, maybe you don't really care to have those other adapters hanging out because they're not valuable to you. And so maybe you want to turn them off. And I'm trying to rack my brain. Nitish Malhotra had delivered the ability to provide Meshery CTL a config file. And Nitish, I don't remember, I'm pretty sure, like, help me recall if that Meshery CTL config YAML would cover Meshery.yaml, like, or are those two concepts still separate?
Yeah, they're still separate, and one of the open tasks was to generate the Meshery CTL YAML file. So far, we just have support for it, and we tried it by manually creating one. So there was talk of merging both the YAMLs, but the Meshery YAML today is just a Docker compose file. So yeah, I think we discussed that the config file should be its own entity and the compose file should be its own thing.
So Nikita, there's good and bad news. And part of the good news is that, in addition to the point that you can quickly do what you're looking to do right now with no code change in the project. And in Slack, we'll highlight where you can disable the other adapters. As a matter of fact, Miku, I might even challenge you to try to answer Nikita's question, because I think at this point, I think you're familiar enough, you'd be able to take it on. So I'll connect the dots in Slack after this, just noting the time. But in Nitish, where do we go? How do we go about generating the Meshery CTL config YAML, like, for the first time?
For the first time, you mean manually?
Yeah, I think so. Or yeah, I guess I'm ignorant here. Like, is this a format that we just need to make up and just define ourselves, or is this a format from Cobra that
it uses Viper? Viper is the config loader by the same guy who created Cobra. But we did define a few fields which were constants, defined as constants in our code. And yeah, I think what we had done is build a simple YAML file, and we said if the YAML file doesn't exist, we are going to use some hard-coded constants. If it does exist, we override them.
Okay, so there's no, all right, very good. Viper itself doesn't impose a specific format other than just syntactically YAML correct.
Just YAML, yeah.
Okay. Well, good. Well, Miku, if you're accepting the challenge, I'll describe Nikita's question to you in Slack, and we'll get her up and going. Nikita, out of curiosity, which service mesh is it that you are most interested in, or the one that you're looking to use?
There is as such no specific, but I am looking for those service meshes which are supporting VMs. So, okay. Yeah. So mostly like Puma, Istio also has come into this. So yeah, I'm looking into those mainly.
Cool, and Consul as well, which is...
Yeah, Consul is also.
Shriti, I'm sorry that I took us a little over time. Do we have anything else we need to?
That's all right. Michael, I think Lee will text you on Slack. Also, if anybody is looking for the design spec for the API structure of Meshery, and it will left a link. It's available in the meeting minutes. I think he'll elaborate on it in the next meeting. We're already 5 minutes up. So thank you for coming, everybody. And we'll catch up in the next meeting.
Nice.
Thank you. Bye.
Yeah. Talk to you later.
Bye-bye. Bye.
Bye.
Bye, everyone. Bye.
Thanks, guys.
Hello, Shivam.